Okay, 6th grade, happy Thursday. Thank you. So we are going to start with our on graphing in slope-intercept form. We are going to move on to parallel and perpendicular lines today, and I have an interesting homework assignment for you guys tonight if we get to it. So we'll see how that goes. Okay, number 1. Can you graph this just like it is? No. Matt, what do we have to do? Good. Put it into slope-intercept form. So can someone tell me what the slope-intercept form is to number 1? Emma M? Good. Y equals 4/3 x minus 3. So I have it right here. Okay. Slope is 4/3. Y-intercept is 0, -3. When you graph it, start at -3, go up 4/3, up 4/3, etc. So there's warm-up number 1. Questions? Zach, you sure it's not still in your backpack? You can borrow packets for today if you want. All right, number 2. Anyone think they got the slope-intercept form on this one? Briar, what do you think? You got to get rid of the 1/2 y. So you're actually right, but you got to get y. You got to get it into y equals form. Okay, now multiply everything by 2. Get it into y equals. There you go. See that? Yeah, I know what he meant. Okay, y equals -2x plus 6. Y-intercept is 0, 6, so you start there. Slope is -2/1, so down 2 to the right 1. Down 2 to the right 1. Annalise. Did you redo it, though, once I told you what to do? Distribute the 1/2 through. Okay, so you get x plus 1/2 y equals 3. Then minus x. Well, what's 2 divided by 2? Yeah, just change it to a 1. And then minus x on both sides. So that's probably what messed you up. And after that, minus x, excuse me, on both sides. So we get 1/2 y equals -x plus 3. And then last thing, like I told Briar, multiply everything by 2. Okay, you're right here after you distribute. So then you just minus x on both sides. And then you get this, what's inside parentheses. Yep. So it's much easier than it looks. Shona, did you get that one?
Oh, yeah.
Okay. Just making sure because you weren't here yesterday. Matt? One second. That's fine. Well, you mean, well, if you divide both sides by 1/2, that means that you have -1 divided by 0.5. -1 divided by 0.5 is -2. 3 divided by 0.5 is 6. So you probably typed it in your calculator wrong, Matt. I recommend changing that to a decimal if you're using the calculator. And I would do -1 divided by 0.5, 3 divided by 0.5. You know what I mean? Okay, Annalise, go ahead. You tell me that. How do you know when to stop? It has to be y equals mx plus b form. All right, anyone else on number 2? Okay, let's go over the homework. What did you guys think of the homework? Okay. All right. Wait till you guys get it out. It was pages 140 through 141. There were actually 3 different sides to it. Thanks, Briar. Sorry. Yep, that's what Emma H. was all confused about. All right, Matt, we'll start with you with number 1. Good. Slope-intercept form. Emma H., number 2. Okay, but you didn't answer the question of what is another name for slope? You forgot. Look in your notes. Mary? Good. Rate of change. How else can we represent slope, Justin? Good. Rise over run. So anything like that. So a little more than just M. Just putting M just answers the second question. Okay, Annalise, number 3. Good job. An ordered pair, B, and it's written as 0, comma B. Same thing as 0, comma a number. Okay, Doug, number 4. Can you tell us what your Y equals was, your M, your B? Good. Good. And the graph is a positive linear function. Charles, make sure you're checking your homework, please. Quit graphing random things. All right, number 5. Jeremy, you don't have any of it done? Why don't you take it out so you can follow along with us? Okay. Mary, number 5. Good. Good. Awesome. So here's what the graph looks like. It's a negative linear function. Donatus, number 6. Nope. You messed up one little thing that's going to mess up. No, it's positive 1/2. It's your 2 shouldn't be there. Okay, well, good, -1. So then M Donatus is what? Good, and B is -1. So 1/2 x minus 1, 1/2, and then 0, -1. Okay, when you're ready, let's go to 7. Zach, do you have yours, Zach, or no, because you don't know where your binder is? Okay, Justin, number 7. Good. Good. Good job. Positive linear function. Started at the origin, go up 1/1. Emma M, number 8. Good. Good. Awesome. What does the graph look like? This or this? Good. Good job. This or this. Or we could just say vertical or horizontal. Okay, so there's no y-intercept when it's x equals a number. Okay, it never is going to go through the y-axis. Your slope is always undefined. It is not a function. Annalise. Okay, well it's all the opposite of that, Annalise. And don't forget, you can look back in your notes. We have some of these in our notes. Okay, or Annalise, make a table. If you don't know how to graph it, make a table, make all the x values -3, and make y whatever you want. Okay, if you don't remember that x equals a number goes this way, make a table. If it's x equals a number, your slope is always undefined, and there's never a b. Okay? Whoops. No, you tell me why there's not a y. Yes. Okay, green light's back on. Hopefully we're back. Okay, anyways, yes, if it's x equals a number, there's never going to be a y. It can't just magically appear. Okay? All right, number 9, Adam. Left off with you. Is there a y in number 9? Good, so y equals 5. Adam, what's the b? Where is it going to go through the y-axis? 5. Okay? So 5, 0, 0, 5. Just be careful on that. Y equals a number is always a horizontal line. Okay? Slope is always 0. It's always going this way. Annalise. Okay. You're going to have to keep going over those then. Look back in your notes. But y equals a number, Annalise. It's always going to go through the y-axis at that number. So maybe your graphs are just backwards, and that's why you're getting confused. Y equals a number is always a horizontal line. X equals a number is always a vertical line. Yes, correct. But there won't be that many cases like that. If it's y equals 0, it would be down here.
And there's never any slope.
With y equals a number, the slope is 0. There's no, remember the people mover at the airport? They're just going at the same speed. There's no rate of change. Yeah. There's always one if it's y equals. Correct. Mary. Nope. Yeah, and think of it this way, okay? So when you have x equals a number, okay, it's a vertical line, okay? If it's a vertical line, think of it that we cannot walk up a wall, or think of it as you cannot ski down a vertical hill. That's not even the right thing to say, but you can't ski down something that's vertical. You're going to die, okay? If you try to walk up a wall, you can't do it, and don't even tell me you can, okay? So think of it this way, okay? If it's a vertical line, quiet. Okay, if it's a vertical line, think about we can't walk up a vertical wall. Put an X through it. You can't do it. So associate X going through the vertical line. You can't do it. So it's always X equals a number if it's a vertical line, because you can't do it. It's impossible. That's why the slope is undefined. That's why there's not a y-intercept. Doug. It should be 0. You're right, it's still none, but it is 0. Jeremy? Okay, but just without holding on to anything, we can't walk up walls. Okay? All right, we're not arguing about that. Okay, number 10, Briar. Oh, 10, not 11. Okay, so if B is 8, this should be 8. You said 16. This should be 8. Okay. And negative linear function, it starts at 8, goes down 3 to the right 2, down 3 to the right 2. All right, Sean, number 11. Good job. 0, 2, and then positive linear function. Make sure your graph looks like mine. Charles, number 12, you got the hard one there. Okay, what's M? Okay, what's B? Good. Mr. Warnock, what's up? Oh. Yeah, he did. Was he looking at something or? No, I think he just saw me. Okay. All right. So anyways, raise your hand if you got that one right. Just curious. Okay. Oh, that was a hard one. Okay. We'll come back to questions. Yeah, 7/1 is fine. Yep. All right. 13. Let me go over this one because I think some of you got it and some of you just didn't read carefully and didn't know what to do for some reason. All right. 13. Letter A asks you to fill in the equation. Okay. If Jeanette does not have any amount per mile, but she has a fixed amount of $35, she does not have a number by X. So her equation is y equals 35. Ben has a fixed amount of an amount per mile of 2 and a fixed amount of 20. 2 times the amount of miles plus the fixed amount of 20. You pay a fixed amount once. The number in front of X is what's constantly changing. It's your rate of change. Okay? $2 every 1 mile. $2 every 1 mile. Annalise. Nope, you always want them to be in y equals mx plus b form. No. Fixed, Annalise, remember, a fixed amount you do once. We talked about this the other day. B is always your starting point. It's what you do once. The y-intercept is what you do once. It's a fixed amount. Okay? If there's not one, then it's going to be plus 0. This number is the amount per mile, 5x plus 0. Mary, oh, you're on here. 3x plus 15. Okay, the fixed amount is always b. You do that once. Just like in that word problem we did 2 days ago. Okay, before we go to b, questions on how to get the equations. Raise your hand if you had those right, or at least most of them, I should say. Okay. Okay, good. All right, b. Write an equation giving the total amount of money y that you will raise from the donors on your street if you walk X miles. How do we figure this out, Sean?
Y equals 5x plus 17.
Awesome. Did you get that completely on your own?
Yep.
Tell me how you did that.
Well, you
Good
would
job.
you would
I
add
know.
up all the x's, which is 2 plus 5 plus 3,
Yep. Yep.
and then all the fixed amounts, which is 35 plus 20 plus 15,
Good. I don't know. I don't think it's hard, but some people thought it was confusing. So I'm just excited that you got that. And you read carefully and you knew what to do. And anyone else that got it, I'm proud of you. Okay, so B, add up all the like terms. You're just finding the total equation. Now, it's kind of weird. I don't know when you would do this in life. When would you add up everyone's equations? To me, I'd rather graph them all and compare them, but whatever. They want us to add them all up. I know. It's still, yeah. I mean, I guess there is a point.
Oh, and it means that something
Yeah, that's true. Yeah, it's just kind of odd to me. But yeah, I guess if you want to find the total amount of money raised, you could do that. To me, it's easy just to plug the x into each of them and then add it all up. But I don't know. Doug, question? All right, letter C, right? Which equation on the graph has the greatest slope? Explain why this is so. Okay, what do you guys think about C? Briar. Good. Why B? Oh, geez. Okay. Well, you're right. Emma M. Good. 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 So from part B, guys, look. This has a slope of 10. They're trying to trick you. The larger the slope, the steeper the line.
Wait, we were allowed to use that?
Yeah.
Oh, yeah.
No. Nope. What equation? It didn't specify where you had to look. Somewhere in the problem. I know the 5 in that table is, of course, the greatest, so it's going to be the steepest. But in part B, 10 is the greatest slope. Let me guess, Sean. You got that one wrong now.
Yes.
Oh, man. You did so well on B. No, I'm just kidding with you. All right. That one was kind of tricky. I mean, if this was a test and you put 5, I would have let you go. Jeremy. What do you mean, a thing like this? Yeah. A lot of things like this. You can raise money for things. Mary. Yeah. That's great.
And then the next day she couldn't.
I'm sure. It's great. All right. We're going to stop on stories. Okay, 14. Justin, letter A. Don't know where you got 5. Maybe you accidentally looked at the other problem. Alyssa? Yeah. Justin, did you mean to say 25? Okay. You don't need to subtract them. They give you the slope right off the bat. Letter B, where do you put that 110? In for y or in for x? Mary? Good. Put it in for y. So, Mary, what did you get? Good job. There, you guys did better than I thought. Annalise? Okay. Okay. Shouldn't be 1x minus 3. So real quick. So you add 7/5 x to both sides. So did you add 7/5 x to both sides first?
No, first I multiplied.
By what? Okay. So if you multiply by 5 first, tell me what you had.
Negative 7x plus 5 plus 20.
Okay. So what did you do next?
I did put it in like I subtracted 3.
Okay, so then you have negative 7x plus 1y equals negative 3. What'd you do next?
Added negative 7.
You mean add 7. Add 7x.
Yeah.
Okay, so you have 1y equals 7x minus 3. That's the answer.
Wait. I did 1y equals negative 3 plus 7x. Then I divided by 1.
Yeah, but 7 divided by 1 is 7.
Yeah.
Okay, so you have it. All right, anyone else on the homework? Doug, quick. All right, let's go to our notes to page 20. Let's go to our notes to page 20. Good job on the homework. All right, this is kind of a quick lesson. What do you guys know about parallel lines? What do you guys know about parallel lines? Emma H. They're very parallel. That doesn't tell anyone anything if they don't know what parallel means. Donatus. Yeah, you're right. Parallels like this. Matt, what do you know about parallel lines? So they never, ever, ever cross. They're pretty boring. They just keep going and going and going and going. Charles, what do you know? Okay, they hate each other. Annalise, what do you know? Good. Good. Shh. Well, they, sometimes, but they still could cross. Sometimes. Yeah, actually, yeah, the sides of the ladder. Briar. Good, mollusculators. Okay. What else about a parallel line do you know? What else about parallel lines, Emma, do you know? They're the same distance apart. So what about the equations is the same? Anyone figured that out yet? Mary? Nope. Charles? Good. Same slope. Why? Who can explain that? Why would parallel lines have the same slope? This is basically the whole lesson. Adam?
That determines how back straight you go. It has the same.
Yep. So the rate of change is the same. So if one line's going up 2 over 1, up 2 over 1, then the line over here, up 2 over 1, up 2 over 1, up 2 over 1. They're going to be the exact same distance apart the entire time if the rate of change is the same. Okay, what do you know about a perpendicular line or perpendicular lines? Justin, what do you know? Good, they intersect like this. What else, Emma?
I have a feeling that one's going to be on the y-axis.
No, they could be, don't have to be. Annalise, what else do you know?
About their slopes. I'm guessing what they might be. Like, not.
Say what you're going to say. Say what you're going to say. They are opposite. They are opposite something when you think of perpendicular lines. Excuse me. Hello? I am. That's okay. Oh, I didn't know who this was. Go ahead. Okay. It was just 1 to 6. No, that's okay. Bye. Anyways, so yeah, perpendicular lines are opposite something slopes. Jeremy? They don't have to be in a right triangle. Well, yeah, that's what whoever told us that. They make right angles. We have that part. Yep. Donatus. Yep. Slopes have opposite signs. Good job. Briar? Good. All the lines going forever. Okay, let me give you the definition so we can add more to this. Okay, parallel lines, I want you guys to write down have the same slope. And the symbol for parallel, surprise, surprise, are 2 lines next to each other. Okay? In geometry, you'll use this a lot. Okay? Symbol for parallel, 2 lines next to each other. I might have told you that already. Shh. Hey. So then after you write down the examples, I also want you to draw. Here's what parallel lines could look like. So parallel lines have the same slope, which means the m value is the same. There's two examples of equations, and there's what the graph could look like. Annalise?
But those equations aren't.
What's the same in them? Okay, what's the same in them? Be more specific. Look at the definition. What's the same in them? Yeah? What does the definition say? They have to have the same what? Yeah. So do the equations have to be exactly the same? No. If the equations are exactly the same, what would the graph look like? If the equations are exactly the same, Briar, what does the graph look like? Yeah, they're going to be like this. They're not going to be parallel. They're going to be the exact same. And that doesn't help us out with parallel lines. When you have example of parallel lines, the slopes have to be the same. Alyssa? No, they're functions, because when we determine if it's a function, we look at them individually. We don't look at them together. I'm glad you're thinking. Adam? Yep. Okay, perpendicular. Thanks for transitioning me there. Perpendicular lines have opposite reciprocal slopes. Perpendicular lines have opposite reciprocal slopes. So I'm going to talk about what that means in a second. The symbol for perpendicular is an upside down T. The symbol for perpendicular is an upside down T. Here's what, we kind of talked about this earlier. The graph of perpendicular lines are going to somehow, some way cross. Okay? They have opposite reciprocal slopes. So two examples are y equals 2x plus 3 and y equals negative 1/2 x plus 3. Why? Hold on, Adam. You gotta raise your hand. Why are those slopes opposite reciprocals? Anyone want to explain? Doug? Okay, that's the reciprocal part. Why the opposite part? Tell me why. That doesn't help anyone that doesn't know what opposite is. Why are they opposite, Doug? Okay, opposite means one's positive, one's negative. Okay? Don't say they're opposites, okay? If someone asks you, opposite reciprocal, flip it, change the sign. Flip it, change the sign. Perpendicular lines must have opposite reciprocal slopes. We don't care about this. I don't care if these are the same or different. All we care about with parallel and perpendicular is that the slopes are related, like I told you. Opposite reciprocal, the same. Opposite reciprocal, the same. Emma, or Adam, go ahead. Nope, I just said that. Nope. The y-intercepts can be the same, but they can be different. That's completely irrelevant to this section. Emma? No, I'm just doing that to overly emphasize that they make a right angle. No, you will not ever do that. Briar? I figured I'd just be annoying and keep drawing it. Go ahead, Briar. Well, if you're looking at both lines, yes. But if you're looking at just one line, no. When you get into quadratic functions, one quadratic function will have two x-intercepts. So for a linear, they will each have one, but if you're looking at them both together, yeah, there'll be two. Yeah, could have two, I should say. Annalise? You tell me. If you look at just this line, is this line by itself a function? Yep. Is this line by itself a function? Yeah. No. You only look at, is it a function? You look at one at a time. That's what Alyssa asked about this one. All right, let's do an example. Okay, number 1. Find the slope of each line. Determine which lines are parallel. How do you find slope? How do you find slope? I feel like it's been a while. Mary? Good. So you graph it and you count, or you use the formula. Let's use the formula. We're beyond the whole counting part of this. So x1, y1, x2, y2. Go ahead and find the slope of line A. I'll walk around to make sure you guys are getting it. Find the slope. You okay? Find the slope of line A. Good. Good. Wait. Is that a negative? No. Okay. Try this one again. That's not right. Good. All right, Jeremy, what's the slope for line A? Good. Slope for line A is 3/4. Let's plot the points for line A. Over 2, up 5, and then -2, up 2. So plot the points for line A, connect them, label it line A. Annalise? No. No. Y2 is 2, y1 is 5, so 2 minus 5 over -2 minus 2. Get -3 over -4. Okay? All right, go ahead and get the slope of line B and line C. Then we'll graph each of those. So go ahead and find the slope of B and C. Line A, did you plot them? To the right 2, up 5. To the left 2, up 2.
But where do you start?
You're just plotting points, Doug.
But shouldn't it be like that?
Doug, listen. To the right 2, up 5. Okay?
You have it to the left too.
The first one, to the right 2, up 5. That's the first one. Over to the right.
Oh,
Okay.
I see.
The left point is to the left 2, up 2.
Yeah, I don't know why I didn't.
Okay. You should be using a pencil in math. Okay. Do not bring a pen. Okay. Bring a pencil tomorrow. Regraph them and just draw the line darker. You should be finding the slope of B and C. That's not right. It's y2 minus y1. It should be -4 minus 1. You used the wrong numbers. All right. Slope for B, Mary, is what? Good. Slope for B is 5/7, so I'm going to graph this one. You're just plotting points, guys, don't forget. Over 4, up 1 for line B, and then -3, down 4. Connect them. This is line B. And then, Charles, what did you get for the slope of line C? Good. Slope for line C is +3 over 4. So if we plot the points for line C, over 2, up 3, and then over -2, up 0. I'm going to label this line C. Now, this proves that you can't just look at a graph to determine if they're parallel or not, because doesn't it kind of look like they're all parallel? By the way I drew that. What two lines are parallel in this problem? Matt? Good. So to write that, guys, you do A parallel to C. Make the symbol in between it. A parallel to C. Underneath it, it says lines that are parallel have the same blank. What are we filling in, Justin? Good. Slope. Lines that are parallel have the same slope. So your notation is going to be A parallel to C. Pretty easy, right? Parallel lines have the same slope. Proving that you do need to use the slope formula to find slope to prove whether it's parallel or not. Do not just graph it. Okay, it's not going to help you out. Let's try, well, okay, next page, let's go to the top. Next page at the top, it says, for parallel lines, if two non-vertical lines in the same plane have the same slope, then they are parallel. Right here. And then, I don't know, I think this is kind of unnecessary, but second part says if two non-vertical lines in the same plane are parallel, then they have the same slope. Your book is just really trying to emphasize that parallel lines always have the same slope, every single time. Annalise? They can, but they're not functions. So that's why they say non-vertical. Yeah. And you won't ever see vertical lines that are parallel. All right, when you're done with that, flip over to page 22. And on 22, the box at the top says perpendicular lines. You might want to make the symbol for perpendicular so you don't forget. And I want you to fill in, if two non-vertical lines in the same plane have slopes that are opposite reciprocals, then the lines are perpendicular. And the second part says, if two non-vertical lines in the same plane are perpendicular, then their slopes are opposite reciprocals. Perpendicular lines always have opposite reciprocal slopes. When you write that, I want you to go to 7A, the last one we're going to do today. Okay, 7A. How do we do this one? How do we do 7A? Mary? What do you need to use? What do you need to be given to use that formula? Y2 minus Y1 over X2 minus X1. What do you have to be given? You need to be given two ordered pairs. Are we given ordered pairs here? Nope. So what do we do here to determine what equations are perpendicular? So notice, what are we doing? Good. Put in y equals form. So let's do that for A. Minus 2x on both sides. You get 6y equals negative 2x minus 3. Is this in y equals form? Nope. Divide by 6. So what is line A in y equals form? Adam? 10 thirds? How do you get 10 thirds? Negative 2 over 6. I don't know how you got 10 thirds. Okay, negative 1/3. I'm trying to figure out how you got that. Minus what, Adam? Good, minus 0.5 or minus 1/2. So there's A, okay? We already have B. C, Alyssa, is that in y equals form? Nope. So for C, add 1.5x to both sides. So we get 4.5y equals 1.5x plus 6. Then what, Briar? Good. Okay, so what is C in y equals form? You know, you're probably going to have to use your calculator. Alyssa, what did you get? Good. Y equals 1/3 plus 1.3 repeating. You may also keep that as 4/3. Okay, you guys with me on those? How to get that in y equals form? Doug? You tell me. Do we have to do B? We just talked about that a couple minutes ago. B, I circled up there. Why not, Doug? Why don't we have to do B? It's already in y equals form. Okay, what two lines are perpendicular? Emma M. Good. A and B are perpendicular. Okay, so you can write it out as A is perpendicular to B. They have opposite reciprocal slopes, so they are perpendicular. Are any of those lines parallel in 7A? No, none of them have the same slope. Matt, did you have a question? A has negative 1/3, C has positive 1/3. Yes. Did you get a negative 1/3 for A? No, C has a positive, A has a negative. You okay? All right, so the interesting homework I was going to do today, I'm going to save for tomorrow, but you guys have in your homework packet, practice 8.5. There's two things you have. Perpendicular has opposite reciprocal slopes. Parallel has same. If you remember that, that will always be really easy. Okay, practice 8.5. You guys are going to do 14 to 19. And the cow puzzle that you've all been excited about. On page 126 is something different. So let me just explain these. Okay, listen carefully. 8.5, 14 to 19. You need to make sure that they are in y equals mx plus b form. You're writing down what the parallel slope would be and what the perpendicular slope would be. So if it's parallel, the slopes have to be what? Doug? Good. If it's perpendicular, the slopes have to be what? Mary? Good. Opposite reciprocals. Here is the cow puzzle. Cow puzzle is something a little different. Make sure they're in y equals mx plus b form. Graph them. Okay? Make sure they're in y equals mx plus b form. Graph them. Cow puzzle is not based on parallel perpendicular. This is based on parallel perpendicular. Got it? Okay. If you guys are good, you can get packed up. Annalise. Okay, I just explained that. This one. If it's parallel, you write down the slope has to be 12. If it's perpendicular, write down the slope has to be negative 112. What did we just learn today? Parallel lines have what about the slope?
The same.
Yeah, so if it's parallel, you write down the word parallel or use the symbol, and you put m equals 12. Write down the parallel symbol. M equals 12. Yeah, just write down m equals 12. They're just asking you, based on the slope, if it's parallel line, what does the slope have to be? The same. So you just rewrite the same m. If it's perpendicular, what does the slope have to be for it to be perpendicular? The opposite reciprocal.
Oh, negative.
Yeah, that's it. It's easier than what we did in class. Make sure they're all in y equals form for you to do that. You got to put it in y equals form and